Hello and welcome to this webinar about data visualization, principles for the graphic presentation of data. My goal today is to get you excited about how powerful visualization can be to tell stories to readers and also to discover interesting facts about any kind of data. First of all, I would like to talk a little bit about myself, who I am and where I come from. My name is Alberto Cairo, and I am a professor of visualization and information graphics at the School of Communication of the University of Miami. I teach courses on how to communicate using graphics of different kinds, statistical charts, maps, diagrams, different kinds of illustrations, etc. I am also part of a center at the University of Miami called the Center for Computational Science, where I collaborate with scientists of different backgrounds, marine scientists, statisticians, etc. But I didn't begin my career as an academic. I began my career in the news industry as a journalist in media publications, in news publications like El Mundo in Spain. I'm originally from Spain. And between 2000 and 2005, I was the director of infographics at El Mundo, which is the second newspaper in terms of circulation in Spain. At the time, most of my work consisted of basically visual explanations, so using illustrations, 3D animations, and renderings to tell stories, to explain complex stories to people, stories about science, about sports, breaking news events like the terrorist attacks in Madrid back in 2004, etc. And right after that, I moved to the University of North Carolina in Chapel Hill for almost 5 years, where I taught courses on infographics and data visualization as well. Right after that, I moved to Brazil for 3 years. I was the director of infographics at Editora Globo, which is the magazine division of the largest group of communication in Latin America, Globo. And my work started shifting more and more towards depicting quantitative data using charts and maps and different kinds of diagrams. And that is going to be the focus of the webinar today. It's going to be a very quick introduction to certain principles of data visualization. This webinar is also intended to introduce a course on data visualization in which I will discuss these principles more in depth, and we will also teach you how to apply them using Microsoft's Power BI, creating different kinds of graphics, maps, charts, etc. with Microsoft Power BI. The links to these videos can be found on this same page where you are seeing this webinar. I would like to begin by defining what visualization is, what visualization means. A visualization, as I describe in both my books, The Functional Art and The Truthful Art, is any kind of visual representation that is intended to let you see things that you cannot see otherwise. So for instance, you can begin by exploring an Excel spreadsheet with tons of numbers, and it may be really, really difficult for you to see any kind of trend, to spot any kind of pattern from the data if you only look at those numbers. But then suddenly you decide to transform those numbers into a statistical chart of some kind, a bar chart or a line chart, etc. Suddenly you will begin being able to see changes in the data that you are analyzing. I'm going to illustrate this point with a very, very simple example. It's an example that comes from a wonderful book titled Misbehaving, The Making of Behavioral Economics by Richard Thaler. Richard Thaler is one of the founding members of the field of behavioral economics. And in this book, he describes a very, very interesting experiment that he made in class. Many years ago, Thaler used to grade his students in tests on a scale from 0 to 100. And the average score that the students get in tests, in Thaler's test, was 72. So most students got around 70 something over a top grade of 100. And the result was that Thaler's students were not really, really happy. He got a lot of feedback from students saying that they were not really happy with the median score that they were getting in those tests. It was apparently only 72 over 100. And what Thaler decided to do was to transform this into a class experiment. He decided to start grading his students. Instead of using a scale from 0 to 100, he decided to start using a scale from 0 to 137. So 137 became the top score that students could get in his grades, in his tests. And the result was that the median score became 96. And his students were really, really happy. After he made this change into the scores, students started getting super happy about this median score. But the question is, why? Why did this happen? Because the thing is that, as Thaler explains in his book, 72 over 100 is a much better score than 96 over 137. This is really difficult to understand if you don't visualize the data, which is exactly what I did on the next slide. This slide over here represents those data using a data visualization. You can see both the scales from 0 to 100 and the bottom scale from 0 to 137, and you can see the relative positions of 72 and 96 over those maximum, in comparison to those maximum scores. And you can immediately see, your eyes and brains will be able to immediately see that 72 is a slightly better score than 96 over 137. This is the kind of comparison, this is the kind of insight, this is the kind of a story that you can only spot and that you can only tell if you use data visualization. Data visualization is becoming extremely popular in news media. Media organizations, for example, like the Wall Street Journal, are using visualization on a regular basis. One of the most famous projects that they published in the past few years is a collection of graphics that show how effective vaccines are at getting rid of certain diseases. So the graphic that you have on the screen right now is a heat map. The intensity of color represents the amount of cases of measles recorded on every state of the United States from 1950 up to the year 2000. And the vertical line that goes across the graphic represents the time, shows the year when the vaccine against measles was introduced. And immediately the story becomes clear. Before the vaccine was introduced, tons of cases of measles were recorded on all states in the United States. All colors in the graphic are extremely intense before that black line. But right after the black vertical line, measles disappear from the map. That is the kind, again, of insight that you can get only if you visualize your data. Try to imagine this story told only through numbers, told only through Excel spreadsheets, for example. It will be impossible to understand what the message of the story is. It is only when you transform those numbers onto some sort of graphic, onto some sort of visual image, that your brain, your eyes and brains can begin understanding what the story is. Data visualization also has begun winning Pulitzer Prizes. If you go to the Pulitzer Prize website, the latest edition actually shows a couple of prizes that were awarded to projects that are based on data visualization. For example, the Washington Post recently won a Pulitzer Award thanks to a visualization-based project on police shootings all over the United States. It's a wonderful, wonderful project that uses tons of different kinds of data visualizations, data maps, statistical charts, data tables, even pictorial representations. The Tampa Bay Times, which is a news publication based in Florida, also won a Pulitzer Prize recently, thanks to a data visualization that depicts failing school districts in Florida. Again, it's an incredible project that I would encourage you to visit and enjoy. But visualization is not just used and popular in news media. Non-profit organizations and think tanks are also using visualization to tell stories to people, to convey reliable information to the general public. A great example of that is the Pew Research Center, for example, that uses statistical charts and data maps on a regular basis. Now, the key question, I believe, at this point is, how do you get started in data visualization? Let's suppose that you don't have any experience whatsoever creating statistical charts, data maps, diagrams for information, etc. How did you get started? And my answer to that question is with a combination of understanding the core principles of data visualization, the conceptual side of data visualization. For example, learning how to use graphics like the scatter plot or the bar graph or the line graph, etc., but also learning how to use certain software tools that will enable you to put those principles into practice. Just to give you an idea of the concepts and contents that we are going to cover in the next few classes, I would like to discuss some of these core principles. In my opinion, any great data visualization should be first based on good data, meaning that before you even depict the data using a scatter plot or line chart or any other kind of data visualization, first of all, you need to make sure that your data is right, that you have the right data, you have double-checked those data, you make sure that those data are clean, that they have been correctly organized. That is the prerequisite. That's what comes before even you represent the data graphically. Second of all, a good graphic, a good visualization needs to attract people's attention. This is crucial if you're trying to communicate with the general public, which is going to be the main focus in classes to come. You need to basically make sure that the graphic that you are creating is visually elegant, that is attractive to the audience, that is intended to inform. Third of all, a good graphic, after has attracted people's attention, it should avoid frustrating them. It needs to inform them in a way that is simple enough to understand. And finally, a good visualization intended to communicate effectively needs to show the right amount of data, meaning not too much data, meaning not data that can overwhelm people, but also should avoid oversimplifying a story. This is one of the main topics that we are going to cover in classes to come. Let me show you just a couple of examples of projects that don't follow these very basic rules of visualization as well as they should have. So the first project that I would like to talk about is a project that uses relatively good data, but perhaps doesn't show all the data that it will need to show. A while ago, many media publications published stories around a study that had been published by the New England Journal of Medicine. And you can see the headlines of these stories on screen right now. Chocolate and Nobel Prizes linked in a study. Eating chocolate may help you win the Nobel Prize. A correlation between a country's chocolate consumption and Nobel Prize winners is surprisingly powerful, according to a leading medical publication. Right? So all these stories were based on a report published by the New England Journal of Medicine that included a data visualization, included a scatter plot. I'm going to show you that scatter plot, a version that I created based on the scatter plot. A scatter plot is a graphic that is intended to show you the relationship between two different quantitative variables. On the scatter plot that you have on the screen right now, the horizontal axis represents the chocolate consumption per capita and year. That means that on a scale from 0 to 15%, all those countries in there are positioned according to chocolate consumption per capita. If a country is positioned to the left, it means that chocolate consumption is not that high. If a country is positioned to the right, it means that chocolate consumption per capita is high in that country. And the vertical scale represents the Nobel Prize winners per 10 million people. That means that if a country is low on the vertical scale, it doesn't have a lot of Nobel Prizes. But if it is very high on the scale, it has a lot of Nobel Prizes. And as you can see, there is a very strong relationship. In statistics, we would talk about correlation between chocolate consumption per capita and Nobel Prizes, meaning that the more to the right a country is positioned, the higher it tends to be. The more the chocolate consumption in a country, the higher the number of Nobel Prizes that country has. But obviously, as the old saying in statistics goes, correlation doesn't really imply causation. What we are showing is a correlation. There is just a correlation between chocolate consumption and Nobel Prizes, but that doesn't mean that eating more chocolate will increase the likelihood of your winning the Nobel Prize, right? Now, several other publications actually criticized what the New England Journal of Medicine had published, and they actually debunked the results of that little article that this publication had published. For example, the Journal of Nutrition published this article titled, "Does chocolate consumption really boost Nobel Prize award chances? The peril of overinterpreting correlations in health studies." What the Journal of Nutrition pointed out is that obviously you can correlate Nobel Prize chances or the number of Nobel Prizes with many other variables, not only with chocolate consumption. You can correlate Nobel Prizes, for example, with the wealth of a country, for example, with the average income per person. And you will see that there is a very positive relationship between income per person and Nobel Prizes, meaning that the richer a country is, the more Nobel Prizes it tends to have, right? But they make sort of a joke with this story because they try to correlate, for example, Nobel Prizes with wine consumption or Nobel Prizes with tea consumption. Nobel Prizes with wealth, there's a very strong correlation in there, and Nobel Prizes with IKEA stores. The larger the number of IKEA stores you have in a country, the larger the number of Nobel Prizes you have in that country as well. So correlation doesn't imply causation. The problem with the original story is that it didn't include all these other variables that are also perhaps interesting to understanding what can lead a country to have a larger number of Nobel Prizes, right? Now, the other 2 points that I made before is that another 2 important principles in data visualization is to attract people's attention to the data, but also we should avoid frustrating them. After we have attracted people's attention to a graphic, we should avoid frustrating their expectations, for example. Let me show you an example of a graphic that does exactly that, right? This is a completely fictional graphic that I made for one of my books. Let's suppose that you conduct a survey at the University of Miami, for instance, and you ask students back in 1994 and in 2014 as well, you conduct the same survey, and you ask students what their preferred music style is. And the results in 1994, remember, this is completely fictional. In 1994, 35% of the students from the University of Miami said that their preferred music style was hard rock. 25% said that their preferred music style is samba, 20% hip hop, 10% reggae, and so on. And then you conduct the same survey in 2014, and you get different results. And as you can see, I have erased the numbers in there because I'm going to challenge you to make some comparisons in this chart. This chart looks great. It looks, super nice, very attractive. It is very likely that people will see this chart and they will stop and try to read it because it's so colorful, full of special effects, etc. But is it really useful? Can people really make comparisons in here? Now, the question that you should ask yourself is, for example, has hard rock become more or less popular throughout the years? And the answer that you have probably is that yes, hard rock has become more popular, right? But what about samba? Can you really compare samba between 1994 and 2014? You can't, right? It's really, really hard to see if the blue segment of both pie charts is larger or smaller. And then something similar happens with hip hop. Try to compare the orange portions, the orange segments of both pie charts. You cannot really tell. It's super hard to tell if the orange segments are more or less popular. Something similar happens to reggae, right? The challenge here is that we are using graphic forms in an inappropriate manner. A pie chart is not a way of representing change across time. It's a graphic that is intended to show parts of a whole. But the story in here is to represent the change, right? To show the change in between 2 years, 1994 and 2014, right? So it may be much better to show that change using some sort of line chart. For instance, the one that you have on the right on the screen right now shows you very clearly that hard rock has indeed become more popular. Samba has become less popular. Hip hop has increased in popularity. Reggae has stayed the same, right? And then country and classic music, both of them have dropped. These stories or these insights were hidden in the original chart just because we were caring perhaps much more about making the graphic look nice and attractive, etc., rather than caring about presenting the information effectively and in a way that people can see the stories that hide behind the data. In the following videos, we will cover these and many other principles of data visualization. But I do believe that if you really want to get started in this field, if you really want to start using statistical charts and data maps and diagrams to explore your data and communicate those data to the public, the best thing to do is to first think about topics and things and stories that you really care about. You may be interested in politics, you may be interested in economics, you may be interested in sports. What I would encourage you to do is to think about stories that you care about, that you look for data that relates to those stories. You download those data to your computer, and then you start visualizing those data. Let me show you an example of how to do that. It's actually one of the examples that we are going to cover in the following classes. It's a project that comes from Real Sociedad. Real Sociedad is one of the many teams, soccer teams in Spain. It's a very popular one. And a while ago, Real Sociedad partnered up with the Power BI team to visualize data from their players. Let me share my screen with you so you can take a look at this project and how powerful it is at presenting information. So the project visualizes the position of these players according to two different variables. On this scatter plot that you have on the screen right now, you can see the players plotted on the horizontal scale according to the number of games that they played throughout the years. And on the vertical scale, the position of each one of these players on the vertical scale corresponds to the number of goals that they scored throughout the years. The visualization is extremely powerful at letting you explore the data at will. You can use the scrubber bar down here to go back in time, back to 1971, or to move it to the right and see the many players that started playing right after that year. You can click on the play button and get an animation where you can see the players moving around on the scatter plot, or you can hover over each one of the players to get some specifics, or you can click on the dot and see a line that shows you the progression of this specific player, Uriasti, throughout the years according to games that he played and the number of goals that he scored. Then if you click on next using this button over here, what you will get will be a map of the Basque Country region in Spain, showing you where all these players were born. The size of the bubbles placed on the map correspond to the number of players that were born on each one of these cities. And you can see the cities of origins or goalkeepers, defenders, midfielders, or forward. Again, the size of the bubble corresponds to the number of players. Projects like this one from Real Sociedad and many others that we will learn about during the course will show you, or so I hope, that data visualization is not just relevant to understanding your data correctly or to presenting those data to the general public. They are also a lot of fun to design. And to finish this webinar today, I would like to provide an introduction, to give you an introduction to the topics that we are going to cover in classes to come. Class number 1 will be an introduction to the main principles of data visualization for effective communication. In class number 2, we will cover how to use data visualization for exploration, meaning we will show you how you can use statistical charts and data maps and diagrams to extract information from raw data. Class number 3 will show you how to create graphics that don't mislead. We will cover how to create truthful visualizations. On class number 4, we will focus on how to choose graphic forms correctly. We will show you, for example, when it is appropriate to use a bar chart, when it is appropriate to use a line chart, a data map of the data maps of different kinds, diagrams, etc. And finally, class number 5 will focus on certain very basic but also very relevant principles of graphic design, interaction design, and storytelling for visualization. I hope that this webinar and the overview of the contents of the course has gotten you excited already. If that is the case, we will see you soon on video number 1.